All right, and we're back. So let's talk about how to solve this next equation. Again, I'm going to move everything to one side. So I'm going to go ahead and I'm going to subtract 9x from both sides. And if I do that, then we get 6x squared minus 9x is equal to 0. Now, notice that this one does not have a c value or a visible c value, or I guess you could say the c value is 0. So here we have ax squared plus bx plus c is equal to 0. And so here we see that our a value is 6, our b value is -9, and we don't have a plus c attached there, so then c is equal to 0. Now, what that means is that we don't have to use the Xbox method like last time. What we can do is we can just, because there's only two terms, we can just figure out what do those have in common? What's the largest thing that we can divide by both of those terms? And the greatest common divisor of 6 and 9 is 3. So I can definitely factor out a 3, and I can also factor out an x because both of those terms have an x. And so if I divide 6x squared by 3x, I'm going to be left with 2x, and then if I divide -9x by 3x, I should just be left over with -3, and then that is equal to 0. And again, we're going to use the zero product property by setting each of these terms equal to 0 and solving. So if I do that, then I get 3x is equal to 0 and 2x minus 3 is equal to 0. I'm going to solve for x here, so x equals 0, and then I'm going to add 3 to both sides. So I get 2x is equal to 3, and then I'm going to divide both sides by 2, and that yields x is equal to 3/2. So those are my two solutions. And again, we want to plug both of those in. Now, what's really nice is that the addition property of equality says that these two equations are the same thing and they're going to have the same solutions. So what that means is the x values that I have solved for in red, I can really plug them into either of the black boxed equations to check my answer. I'm going to plug these both into this equation here to verify that that's correct. So let me plug in x equals 0 first. So I get 6 times 0 squared minus 9 times 0. And then that's just going to end up being 0. So that is 0 is in fact a root of the equation. So that checks off. Now I'm going to check that x equals 3/2 is also a root. So I get 6 times 3/2 squared minus 9 times 3/2. And we just want to verify that when we simplify that, it gives us 0. So let's see if that happens. 9 times 3 is 27, and then we'll put that over 2. I can put that over 1. So if I multiply those two fractions, 6 times 9 is 54 over 4 minus 27 over 2. Now I can reduce the first fraction. So 54 divided by 2 is 27. So all I did was I divided that by 2. And I divided that by 2. And if I did that, then that gives me 27 over 2 minus 27 over 2, and that equals 0. So that checks off. So I have double checked and verified that both of those are in fact solutions to this equation, but also to that equation because of the addition or subtraction properties of equality. All right, let's move on to example 3. It says, solve the equation y minus 1 times y plus 5 equals 7 by factoring. Now, You might be asking yourself, Mr. Kwan, can I set both of these terms equal to 7 and solve it that way? And the answer is no, because it's not called the 7 product property, it's called the 0 product property. So we need it to be equal to 0. So I have y minus 1 times y plus 5, and I'm going to subtract 7 on both sides. So if I do that, then I get this. But that's not factored anymore, and so we're going to have to do some maneuvering, okay? What I'm going to do is I'm going to use the FOIL method. And the FOIL method is what we do in order to multiply these two terms out. Now you might have heard about it before. FOIL stands for first, outer, inner, and last. So that just tells you what we're going to multiply together. So first we're going to multiply the first terms together, so y and y. If we multiply those, then we get y squared. Then we're going to multiply the outer terms together. So y times 5 is just 5y. Now we're going to multiply the inner terms together. So negative 1 times y is just minus y. And then we're going to multiply the last terms together. So negative 1 times 5 is minus 5. And then we still want to bring down that minus 7 we had from earlier, and we know that that is equal to 0. Now notice that we have some like terms here. So we have these like terms, and then we have these like terms. So we're going to want to go ahead and combine those. Now if we do that, we get y squared plus 4y minus 12 is equal to 0. Okay, now earlier I said, like, for an example like this, we would use the Xbox method. However, if your a value is 1, which it is in this case, we only need to use what's called the X method. So let me write that down. When a is equal to 1, we only need what's called the X method, not the Xbox method, okay? So again, here we have y squared plus 4y minus 12 is equal to 0. Since the coefficient or the number in front of y squared, and you can imagine like a 1 right here if that helps you, since our a value is 1, we only need to use the X method. And it works kind of similarly, we just don't need the box at the end. So I'm going to put b on the top. Our b value is 4. And then I'm just going to put c on the bottom, and our c value is negative 12. And I want to try to figure out two numbers that add to 4. So we put the b value here and the c value here, and we want to figure out two numbers that add to 4 and multiply to negative 12. And if you need a minute to think about it, go ahead and pause the video. But the numbers that'll make that true are 6 and negative 2. So now what that means is we could just factor this into y plus 6 and y minus 2. And that's what that factors into. And then from here, just like we've done in the last two examples, we can use the 0 product property. I'm going to set both of those terms equal to 0. And if we solve them, we should get y equals negative 6 and y equals 2. So I'm just going to box my answers. And I'm going to go ahead and let you verify that those are both, in fact, solutions to either the original equation, so that equation, or the modified equation that we had here. You can plug it into either version to verify that they are in fact correct. I verified them earlier, but I would like you to do that on your own as well.